Okay, so I'm going to go to the question, one of the questions that Kotso gave us to look at. Now, Kotso, your question is nice in the sense that the notation in the question is changing. So let us have a look. The notation says dx, find dx of 5x over the square root of x cubed plus 3x, what's that, plus x to the naught plus 2. Now this question was on some question paper, I don't know which one, but it was for 4 marks. Now people remember, I'm going to put our form down here. If f of x quickly is ax to the n, that's the form that we want, and then only can we differentiate. Now if we look at this question, the notation is also different. So if I look at the notation over here, if I tell you to find dx of ax to the power of n, it means the same as finding the derivative with respect to x of that. So the notation dx and the notation f prime x, and there's a third notation dy dx, is exactly the same thing. It asks you to find the derivative with respect to x. Whenever you see that, check that your form is ready. Okay, so let's look at the first one. The problematic one here is this one over here. That one is fine. That we can simplify. We can replace that with 1 because exponents tells us that anything to the power 0 is 1 as long as that anything is not 0 and that anything a is indeed positive. Okay, so that's our exponential law. So that is fine, and this is fine over here. There's a problem with this. Okay, so I have got to panel beat this so that it looks like that. Okay, so let's do that. How are we going to do that? We're going to write everything as powers and then apply exponential laws, bring the x cubed in the denominator up to the top, and then differentiate. So let's have a look. We're still panel beating, so we keep the notation dx. Okay, so this becomes 5x to the power of 1. That's a power there of 1. And this here, let's do it on the side here for you. 1 over, or let's first deal with the square root of x cubed. Now that can be written as x squared times x, which is rooted, sorry, my square root is a bit misplaced there, but I can see that the square root of x is x, and I have x root x. Now that comes with a lot of assumptions with it. Okay, so I'm going to use the power of the x and take it in its entirety to the top. So what does this become? This is the same, remember there's an invisible 2 in the front there. So that is x to the power 3 over 2. But that's still in the denominator. I must now take that x to the 3 over 2 into the top, from the denominator into the numerator. So I'm reversing. Which law is it that I'm reversing? The law that says a to the m in the denominator is the same as a to the minus m in the numerator. So that goes to the top, and I have multiplied by x to the minus 3 over 2 plus 3x stays. X to the power 1 I can, or to the naught I can replace a 1 there. 1 plus 2 is 3, so a little bit of cleanup that happened there. The last thing I need to do here is combine these two x's with 1 power. So I apply my rules for subtracting fractions. So I've got 5x 1, now think carefully in your head, 1 minus 1.5 is minus a half. There the form is perfect. Okay, so what did we do? We took the root, we wrote it as a power, we kicked it up, we applied an exponential law, it's in the form and ready to be differentiated. So we've got plus 3x left and plus 3, And now we're going to differentiate what is inside of that bracket. So, remember what I said? If we differentiate, we can drop the notation. Now, the derivative of 5x to the minus a half. I'm doing it on the side here, just to explain what's happening there. Remember, the derivative of that by itself says the power comes down, it multiplies with the existing coefficient, which is 5. X has its old power, and this is another trick now. The old power is minus 1, and I must reduce it with a further 1. Okay, so if I do that there, I get minus, what is it, 5 over 2. That's just combining those two, and the x is minus a half, minus another one is minus 1.5, which is 3 over 2. Now, folks, please, that's basic information. You cannot sit in an exam and try and find out what is minus 1 minus another half. Please, really. Get your mind in gear to do the mental gymnastics there for you. You're wasting time if you run to the calculator for every basic calculation. Please remember that. Okay, let's look at the 3x. The 3x, we're going to differentiate separately here. Now remember, the x's power is 1. Okay, so the power comes down. I multiply it with the 3. The new power is the old power reduced by 1. Now, folks, we all know that that gives us 0, and x to the 0 is 1. So the result for this derivative is 3. Now, let's talk about that little bit as a rule. If you differentiate 5x, the same is going to happen. Your derivative is 5. If you're going to differentiate pi over 3x, your derivative is going to be pi over 3. The constant or the coefficient of the x is what remains. Okay. The last one that we need to look at is that constant. Now, we're going to write that constant in the form, let me just extend my page here. We're going to write the constant in the following form. We want dx, where's my pen? We want dx of 3. We're focusing on that constant over there. Now that is 3x to the 0. Now folks, it is in the correct form to differentiate. The 0 comes down and multiplies with a 3, so it's over for the 3. Okay, it's 0 times 3, and that derivative is just 0. So the rule here, both Kotso and Jessica, the rule that I'm applying here is the fact that if I multiply anything with 0, it's 0. So if I take the derivative of a constant, the derivative of a constant is 0. Okay, always file that somewhere as a rule. So if I just have an x and I'm differentiating something times x, then that something is the derivative, the coefficient. If I take the derivative of a constant, it is indeed 0. Now there might be one step left. If you are asked to leave this with positive exponents, you're going to have 5 over 2 times x to the 3 over 2 plus 3. But normally things finish in that step over there. Okay, so that takes care of one of the questions that Kotso sent us. So what did we do? We put it in the correct form, and then we applied our power rule.